Welcome to the Blueprint Atlas. Subscribe and explore nature's greatest engineering secrets together. Steel builds our massive, soaring skyscrapers and suspends giant bridges over deep waters. Kevlar absorbs the brutal impact of high-speed rifle bullets, protecting human lives. Yet, deep inside a quiet, misty forest, a tiny and remarkable architect is working. A nearly blind creature, possessing a brain no larger than a tiny grain of sand. Is spinning a biological supermaterial that easily outperforms both human steel and Kevlar combined. This material displays unparalleled tensile strength and flexibility, baffling human material scientists for decades. Imagine trying to construct an invisible, high-strength structural net suspended entirely in mid-air. It must be light enough that the wind does not rip the fragile structure apart.
Yet, it must remain elastic enough to survive the sudden, violent impacts of flying prey.
A heavy insect is basically a biological missile flying at high, uncontrolled speeds. To survive this impact, the web must absorb massive kinetic energy in milliseconds. The incoming energy must be dispersed instantly, otherwise the entire structure will fail catastrophically. Our material engineers struggle to balance extreme hardness with maximum elastic stretchability. If a material is too rigid, the incoming object simply bounces off unharmed. But if the material is too soft, the structure tears open immediately, letting prey escape. This perfect mechanical balance is incredibly difficult to achieve in the physical world. Yet, spiders solve this complex structural equations every single night in complete darkness. The secret lies in an integrated biological 3D printer inside the spider's body. This incredible organ does not just make one silk, it produces 7 distinct types. Each unique gland manufactures a different protein recipe designed for specific structural tasks. First, they secrete dragline silk, an incredibly strong fiber used for the main frame. These main structural lines act as the load-bearing cables, much like a suspension bridge. This primary frame must anchor the entire construction securely against gravity and wind. Next, they weave the catching spiral using highly elastic flagelliform silk threads. This specialized catching silk can stretch up to 300% of its length. These elastic catching lines are coated with tiny, highly sticky droplets of bioglue. This glue remains sticky in dry heat, heavy rain, and freezing cold temperatures. The adhesive bond is instant, trapping any insect that brushes against the spiral. The finished web is a masterpiece of static load-bearing and dynamic energy absorption. When a raindrop hits, the web behaves like a highly coordinated spring system. The proteins unfold under tension, absorbing the raw kinetic energy without breaking apart. If an impact is too extreme, only the local sacrificial threads will snap. This clever structural sacrifice prevents the entire web from collapsing under heavy pressure. To navigate this deadly maze, the spider walks only on non-sticky radial lines. Specialized non-stick chemical coatings on their legs also prevent them from getting trapped. It is a flawless, deadly trap, optimized down to the very last micrometer. But over a single day, wind and dust gradually degrade the web's stickiness. As dawn breaks, a completely new and surprising phase of engineering begins. Instead of abandoning the worn-out web, the spider eats its own creation. This allows the spider to recycle up to 100% of the protein. The entire recycling process is completed in less than 30 short minutes. By nightfall, they are fully prepared to build a brand new masterpiece again.
But scientists recently discovered an even more shocking feature of these webs.
Spider webs actually carry an active electrostatic charge across their entire surface. The entire recycling process is completed in less than 30 short minutes. This physical difference in electrical charge creates an invisible attraction between them. When a charged insect flies nearby, the web physically bends towards it. The web actively reaches out to snatch the victim from mid-air. The prey is captured before it even makes direct physical contact. This smart trap also pulls in airborne pollutants, cleaning the nearby air.
Human engineers are studying this phenomenon to design smart electrostatic filters.
We are copying nature's design to build better, highly efficient green technologies. So, these tiny creatures are not just simple, mindless web builders. They are actually highly sophisticated material scientists working right in our backyards. Every single web is a testament to millions of years of evolutionary design. A flawless integration of physics, chemistry, and structural engineering working in perfect harmony. As humans look to build the future, we must look closer at nature. Subscribe to the Blueprint Atlas to uncover more incredible engineering secrets of nature. Thank you for watching, and we will see you on our next epic exploration.